Hello everyone, welcome to our learning series of how to use Unreal Engine for architectural visualization. In this video, we're going to answer another request on how to drag and move 3D objects in real time. As you have seen from our previous video, we have learned how to drag and drop our 3D sofas into our 3D scene. In this video, we're going to learn how to build up a basic gizmo setup for the 3-axis direction, the X and Y and Z. So the viewer of your presentation will be able to move the 3D furniture, for example, and arrange them according to their need, and send you, for example, some photos of what he wants in this project. So let's see how we build this basic gizmo. And before we start, we need to mention that this tutorial is inspired by the tutorial created by Lusigenic, and his tutorial was basically addressed to how to move and interact with physical and non-physical objects in real time using Unreal Engine. And if you like to learn more about the physics interaction of the objects, we'll put the link to his page so you can visit his page and learn more on his cool stuff. And this is actually the cool thing about Unreal Engine, is that all the different communities can learn from each other by sharing their techniques. So let's see how we're gonna build this basic gizmo setup. So we started by importing a basic arrow axis that we have modeled inside 3D Max. Just a basic arrow. You can model it in your preferred modeling software, and exported and imported it as an FBX format. And we have 4 different materials will represent the axis, colors, and the highlighted axis. So we will start by creating a blueprint class, which is an actor, and let's name this, for example, Gizmo Axis. And then we're gonna drop a scene, add a scene so we can make it our default scene, and add a static mesh. We're gonna call this, for example, Gizmo root, and add another static mesh. Name this as X and call our static mesh axis, which is X axis. Yes, that's it. So it has the material applied to it, and then we're gonna duplicate this to Y and bring the red material. Actually, sorry, the X is the red color based on the mathematical representation of these axes, and the Y is the green. So we're gonna rotate it on the Z direction by a 90 degree, and then we're gonna duplicate also the Y, name it as Z, and bring the blue color, and we're gonna rotate it onto the Y axis by minus 90 degree. And then we're gonna compile, and it's really useful to disable the lighting and the shadows for this one. So on the lighting channel, we're gonna put this onto the channel 1 so it doesn't receive any lighting effect. And also for the shadows, we're gonna disable the cast shadows, and for the reflection, we're gonna disable the visible and reflection captures. So we're gonna start by creating a line trace, as we have done before in our VR teleport tutorial. So we're gonna start by bringing the convert mouse. We're gonna disable the context sensitive, and bring the convert mouse location, and we're gonna drag from this. Actually, we're gonna enable first the button that will enable the trace for the line trace. And this is going to be a left mouse button, and it's going to be done by a branch where we're going to bring a condition if we're going to left click the mouse and drag our object. So if it is true, we're going to put a line trace by channel. And the location for this, we're gonna start by the world location from the pawn actor. And for the world direction, we're gonna first multiply our vector by a float, and this float will represent the length of the line trace where it can hit the 3D objects and the 3D space. So let's put, for example, as 10,000, and let's then add this to our vector and bring the world location to the end of this line trace, and this is gonna represent the end of the line trace. And we're gonna connect this also to our player controller, and we need to see, for example, the debug, so we can confirm first that our line trace is working. So we're gonna also enable trace complex so our objects can be traceable. So let's compile and drag our actor into our 3D scene, and now we're gonna need to enable also the function to move the gizmo. So we're gonna create a variable and call this, for example, move function, and let's bring here as a set and assign, let's say, for example, the move key. Okay, and let's connect to our variable, and we're gonna get it also, and bring a not boolean and connect it to the set. So this is basically to enable it to be active, and we also want to show the mouse cursor. So we're gonna bring also the show mouse cursor, and basically we need the player controller to connect it to the condition to show the mouse cursor, and we're gonna also get show mouse cursor and connect it here. Okay, so this is the first thing we're gonna do, is to, when we press M, it's gonna enable the line trace function. So we're gonna create another branch and connect it to this one and bring the move function, and this is our condition. So if it's true, the line trace will start. So let's see how we can confirm this by checking if the line trace is visible into our arrows. So if we hit play, and then if we hit M, we should be able to see the mouse left mouse button is not active. If you see this, then all what you need to do is just bring enable input, and then also connect the player controller. So let's compile again and hit play, and then hit M, and we should now start to see our line trace hitting our arrows. So to confirm that it's working, it has to show you this small square at the end of the line trace, and on the other side it will show a degree. So this will prove that the line trace function is working perfectly, and we can move to the next stage where we can bring our hit result, and we're gonna find the hit result information that we're gonna use. The first thing is that we need to get the distance that's gonna be the head from our character to the end of the line trace. So we're gonna just right click and promote to a variable, and this is gonna be, for example, distance to graph, for example, and we're gonna connect this to the trace line trace by channel. Next thing we're gonna do is that we're gonna need to create an enumeration variable, and this is a variable that will help us define which arrow or which component are we hitting with the line trace. So if we're hitting X, it should know the line trace that it's hitting the X component. And to do that, we're gonna start by creating the enumeration variable, and we're gonna call this, for example, axis variable, for example, and let's double click it, and we're gonna create 3 basic names. Let's say start with the X, Y, and the Z. Then we're gonna create a structure that will enable us also to switch between these variables. And this is going to be basically by going to blueprints and creating a structure, and let's call this, for example, dragged axis. Inside this we're gonna need to create two variables. The first one is gonna be the variable which will represent the components that we are hitting. So this is gonna be a primitive component, and we're gonna call this, for example, the axis component, and the other variable will be the one that we have just created, which is the axis variable, and it's gonna be visible inside our enumeration variable. So if you can see in the default values that we have received here, we have our 3 arrows that we're gonna use in our event graph. So now that we have created an enumeration and a structure variable, we can get from the head component the result that will help us to define which axis that we are hitting. And another thing that will help us to do that is building up a function that will define like a condition. When we hit the X, it will know that it hit the X or the Y or the Z. And let's say, for example, name this as axis component, and it will start by creating, for example, an input and an output. Our input will be basically the primitive component, and our output will be the axis which we have created, the axis variable. Let's compile, and let's name this also as axis component, and for the axis, let's say, for example, variable or dragged. So we're gonna get from this, create a variable and call this axis component. Sorry about that. Axis, let's say, for example, dragged, and we're gonna connect it to the axis component, and we're gonna connect this to a branch. This branch will connect it to the axis dragged variable. So I'm gonna give it a mathematical equation equal to the condition, and this is where we're gonna drag our component and connect it to the branch. So we're gonna create another one. First we're gonna connect this to the true, and we're gonna take a copy of these guys, Control W to duplicate it, and if it's false that we're not hitting the X component and we're hitting the Y component, we're gonna change this here and here also, so it will know that we'll choose the other component. And the last one will be the Z component, and that's it. Basically compile, and let's go to our event graph, and this is gonna be the step where we're gonna also need to make this function as a pure, so we can connect it to our nodes here. So we're gonna get from the components the functions that we have created, where it define which axis are we hitting, and from this we're gonna bring the structure that we have created, which is the dragged axis, and we're gonna connect this to a switch. Actually, we need to split this and connect it through the dragged axis enumeration, and we're gonna switch between the axes. So once we connect them all, we need just a final test to give us that the final result that we are hitting this. So let's bring a print string, and once we hit the X, it will show that we're hitting the X and Y and the Z. So let's see now if we can compile. Let's go to our actor. Let's test this out. I'm gonna hit M key and it shows X here. Let's expand this. And so if we hit the Z actually is not connected correctly, so let's review that. Sorry, I'm just gonna change print string to Z. Let's confirm again. You can actually see it also here through the debug simulation. Just make sure that your debug filter is connected to the same actor. So if we hit this, it's actually not showing. We need to press M, and then if we hit the X, you can see that we are choosing the correct arrow with the Z, and it shows also in the print string. So far we have succeeded in creating the basic connection or the interaction between the trace line and the arrows. The next thing is that we're gonna set up the movement function so we can move the gizmo. So we're gonna bring the event tick and connect it to the add relative location, and this is gonna be basically the node that will help us move the gizmo into the axis direction, or the direction that we will define later on, by each frame that is represented by the mouse movement. So to do that, we need to define the location, and the location will be actually calculated by the same measurement that we have done here. So we're gonna copy these here, paste them here, and we're gonna connect the value that we have calculated based on the hit result. So it's like a sequence that happen after another. So once we hit, we get a distance to grab, and we're gonna connect it into here. And now we need to define the location of the actor. To do that, we're gonna need to drag from the dragged axis structure that we have created. We're gonna get a world location of the component that the line trace have hit. So each one of these have a different world location, and we need to get their location, and then we need to inverse the location. And this is where you actually learn more actually inside the tutorial that was created by Lusigenic video on how to drag, where he have explained that when you click or when you use the mouse button to hit an object, if you hit here and the pivot is at the end of the object, without the node that is called inverse transform location, without this node, what will happen is the mouse, when it hits here, the object will snap to the mouse location, and it will create like a flickering effect that is not actually recommended in the presentation. So we gotta connect the world location to the T section here, where this node will inverse the location of the pivot to the location where the line trace have hit. And we're gonna create a variable, promote this to a variable, and we're gonna call this, for example, drag location. And this is where we're gonna connect our 3D arrows by creating also a route, and we're gonna connect the 3 of them to this variable. Sorry. Okay, so once we have created the variable, we're gonna call it here into our add relative location destination. So we're gonna create again the inverse transform location, and we're gonna bring our drag location, and we're gonna make sure that we are connecting this to the transform, so it will invert the location once it hit the actor location. The last stage we gonna build here in the relative location is that we need to move these arrows on their forward direction. So instead of building a different movements axis on the X and Y and Z and add different relative location nodes, basically inside Unreal Engine, the forward direction is basically the movements of each arrow and its forward direction. And this is where we're gonna call a node called project vector onto vector, and we're gonna get for our axis dragged, get forward vector. So sorry about that, this is not the correct node. Forward, we're gonna need the components one. So this is our node. So once the line trace hit the axis, it will calculate the forward vector for this one and connect it to the targets. So it will translate this vector information connected to the add relative location. And of course we're gonna connect our axis dragged, or sorry, we're gonna actually need to connect the gizmo root, because we're moving, we need to, once we move the axis, we need the whole thing to move. That's why we have built the gizmo root that you can represent actually by a sphere or any static mesh. But right now we just left it as it is, and then we're gonna compile and let's see how this is gonna go. So if we hit play now and see how this is gonna go, when we approach the axis gizmo, let's hit move M, and once we drag, we need to connect actually the axis dragged and to the left mouse button branch condition. So once we release the mouse, it should stop, should not continue moving as you have seen right now. So if we go again and try, so if we hit M, you can see now that it's moved on the y-axis and the x-axis, and also in the z-axis, up and down, negative and positive direction. So this is really a basic idea of how to create a gizmo that you can use in your real-time presentation, where you can assign it as an actor, that when you click on an actor it will snap to it, and we're gonna show that later on in our later videos. So if you want to connect this gizmo right now just as a basic setup for one of the static mesh sofas, just to make sure that it's working, we're gonna add another static mesh. I'm gonna call this, for example, sofa 1, and we're gonna call it from here sofa 1. Let's make sure in the editor, so let's just adjust the location of the gizmo root above it, and let's compile. And inside the event graph we need to connect this sofa to the gizmo, so once it's moved it will be moving along with it. So we're gonna call a node called attach components, and this is basically because we are attaching two different components. Make sure you're calling the right node instead of the actor to components. And once we have the node, we need to define that the target is our sofa. This is the one that we want to attach, and our parent will be basically the gizmo, and we want the location to be as it's located in the world. We're gonna compile. Let's see now if we just move this to the third location. So that's enough. Let's hit play, see how this is gonna go. Maximize, and let's hit the M key, and if we move, you can see that the sofa can move into these different direction. And this is where you have the basic setup of how to use the gizmo in real time to enable a kind of an interactive moments into your project for the viewer of your presentation. Now you can ignore these errors as it's not affecting currently the function of this actor blueprints. We're gonna solve them later on, but this is, as you have seen, the basic idea. You can actually expand this to use it in your widget. As we're gonna see later on, we can either duplicate the actor and use it into our drag and drop operation and activate the gizmo based on a widget button, let's say for example as a move widget icon, or we can assign this as an actor, and once we click on the object it can snap to the actor. So we hope that you find this tutorial useful for you, and again, if you have any questions or if you'd like to add anything to this tutorial, please share it down in the comments, and we will make sure to add the videos that we have talked about earlier in the description below. So thank you very much, and see you in the next video.